So,
Probably
on the agenda for today, hopefully, we're just going to review a bunch. If you have any questions about any of these topics, make sure you definitely bring them up today so we get the chance to talk about them. We're also going to talk about a new type that we can use called double. So previous to this, we can use int, float, char, but there's also another type called double, which we'll talk about later. So that's the only new content for today. And then we have a short in-class assignment dealing with random numbers. So reminders, assignment 5 is due this Friday at 11:59 p.m. So if you haven't started it by now, you better get on it, because it is due this Friday at 11:59 p.m. Quiz 3 is available now. You should be able to see that in D2L. Please complete that on your own time. It is due by Sunday at 11:59 p.m. Help night is this Thursday from 6:30 to 8 in 105. If you're going to be there, if you need help with assignment 5, questions about anything we're talking about in this class, send me an email. I will make sure I'm there and we can talk about it at that time. So, questions or comments on anything right now? Yep.
Do you know what the information session hosted by SDBit and the VCI is?
What's your question? So, SDBit is the South Dakota State Information Services. They do all the government's IT stuff essentially for the state.
Like a career day type thing?
Yeah, they're looking for students to do internships and things like that, and full-time employees. They pay South Dakota well. So if you know what that means.
So if I have no idea what I'm doing, I can still get down there.
No.
If you're they appreciate people that are very good at communication. So.
I'm pretty good at talking to people.
Once
I have like 2 years.
Okay. Anyway, so we're going to continue on then. So the first thing I wanted to review was functions. Still a lot of people in here not too confident in their ability to write functions. So this is our original function example from forever ago. So I'm just going to try and talk about it one more time. If there's something that, again, doesn't make sense, stop me and I'll try and explain it in a different way. So essentially what this program does, it declares declares 3 variables. There's one variable which stores 10, one that stores 11, and a third. And then it calls the add function, passing in the value of variable A and passing in the value of variable B, and then storing the result from this function call into C. So when we pass parameters to a function, remember that in order to do so, we need to essentially declare which parameters we want to pass them in and what we want them to be called. So whatever the value is that's stored in A here will be stored in int x, and then we can use x throughout our function body. And whatever the value that's stored in B here will be stored in int y, and we can use it throughout our function body. So then remember that we can say variable equals our function call, and then when we say return a value, it will be stored inside that variable. Now in order to do that, we need to also declare what type of function we're going to use. So we need to say int add if we want to return integers. We want to say float add if we want to return floating point numbers, etc., etc. So again, that's functions. I just want to talk a little bit about this. I'll write out a quick program here. So remember that functions that we write can have any number of parameters. If the very most basic functions only have or take no parameters and return nothing. So remember, void doesn't return anything, but we can still say return semicolon to immediately stop execution of the function. So that's the most basic of functions. So it's void, doesn't return any value, and it doesn't take any parameters. So we can get a little more advanced. We can give it a data type that we want it to return. We can say int. We can say int x, and the very most basic function would just return x. So it takes that parameter. Let's say int main. Int a equals 10, b equals 11, c equals 0, we'll just have C. We'll have C equals fn a, and then 10 will just be passed to the function. 10 will be stored in this variable x, and then we'll return x. So it's essentially just saying call the function pass a, and then we're going to return 10 since that's the value in a, then the value in x, and then we would store 10 in C. So that's a very basic function. Remember that our functions can have any number of parameters so long as our call, so this would be considered a call right here. This is a call. As long as our call matches up with our declaration, so that's this line right here is essentially our the main component of our declaration. So we can say int x, y, int z. We can say a, b, c. We can again pass in any number of parameters so long as we properly declare them, and they don't have to be one-letter variables. I could say result, or like I could say any number of things. I can't think of any names at this time, but just keep that in mind. So that's functions. Any questions about functions? Anything I can help you try and understand at this point? Okay, so going on to, I think loops was the next thing I was going to review. Yeah, so I'm going to go through a couple loop concepts again quick. So remember that we can essentially do 3 types of loops. We can do a for, we can do, let's start with the while loop. We can do the do while loop. And shoot. And we can do the for loop. So these are the basic structures of all the different loops. So in order to actually get these loops to work, remember you have to put a comparison inside the parentheses. So you'd say int a equals 10. You'd say while a is not equal to 0 or any other condition. Remember our comparison operators being greater than, less than, greater than or equal to, less than or equal to, not equal to. I think that's all of them. And then again, a is not equal to 0. And then for loop, in this example, I'll just leave off the initialization. Remember, we can typically the initialization would be here, init, and then we'd have comparison, and then we'd have our increment. But remember that you can leave any component of those off if you want, or you can specify multiple components of each for loop component by separating it by commas. So let's say I had int ij. I could say I equals 0, comma, j equals 0, semicolon to go on to the next section. And I could do as many different initializations here as possible, or as I wanted to. They don't have to be 0. I could initialize j to 10, or I could initialize j to 10 if I wanted to. The only thing you have to remember is it does have to be separated by commas. So remember that when we're doing our comparison, we would say I is less than 10. So that would be a valid comparison. We could say greater than 10, greater than or equal, equal, not equal, all sorts of different things. And remember, if we want to string multiple conditions together, we would say like and to test if both of the conditions are true, and we'd say or if either of the conditions are true. So also remember that when we're doing our increment, we can do multiple increment statements or any other mathematical operations in this component of the for loop. We could say plus plus I, comma, plus plus j. We could say plus plus I and j plus equals 2. If we wanted to add 2 to j instead, we could say minus equals 2 to subtract 2 from j. And again, we could continue to string multiple operations together in this component, which is the initialization component of the for loop, together. So that's basic looping concepts. Go back we're going to talk about nested loops again. I want to run through the example that I had before. So when I'm writing this example, I is going to be our outer index, and then j is going to be our inner index. So I would say for I equals 0, I is less than, we'll say a, and then we'll say plus plus I, and for j equals 0, j is less than I, plus plus j. And then we'll print our index. And then after our loop, we will print a new line. So yeah, again, when I would go about writing this code, one of the things I'd want to make sure I did was comment what was happening here. So I'd want to say outer index. I'd say inner index, just to keep track of which variables are which, because j and I are kind of easily confused, and it's good to let the reader of the code know what is going on. And then I could say limit. So remember, what this program is going to do is it's going to loop. So the outer loop is going to loop from 0 to 9 times, because we're using a less than sign. If we wanted to loop from 0 to 10, we would need to use an equal or less than or equal to sign. So it's going to go from 0 through 9, or it's going to loop 0. It's going to loop exactly 10 times. So 0 through 9 is 10 times, and it's going to run the inner contents of this loop that number of times. So and then this loop is going to loop from 0 to I number of times, which I is the outer index. So it's going to go from, on the first iteration, it's going to go from 0 to 0, so it's not going to run at all. Second iteration is going to go from 0 to 1, so it's going to loop once. Third iteration is going to go from 0 to 2, or it's going to run 2 times. So, and then keep in mind, if we wanted to run that loop on the first iteration, so when I is equal to 0, we want to run the inner loop right away. We want to say j is less than or equal to I. So on the first iteration of the loop, when we first enter, when we're coming from line 14 and we're going down here, so when we're first entering the loop, I is going to be equal to 0, but when the first time the for loop runs, when we set j equal to 0, j is, and we do the comparison, j is less than I, so it's going, or less than or equal to I should say. It's going to test if 0 is less than or equal to 0, and then it's going to be true, so it's going to run this statement once. So just keep in mind that if things aren't working out quite right, do tinker around with the less than or equal sign, equal to signs, or greater than or equal to signs, depending on the circumstances. So one other thing I wanted to do is talk about break and continue. So when you use we'll talk about continue statement first. So let's say I want to skip, I never want to print, let's say 3. I want to always skip 3. So what I would say is continue. Now what continue is going to do is continue is going to skip all the rest of the statements and immediately continue on to the increment step. So instead of printing 3 when j is equal to 3, it's just going to continue on. I'll run this program really quick so you can see that. That's interesting. I think yep, so, okay. So yeah, this skipped 3 every time. But there's actually an error, kind of an error with this program. What is that error? How could I get it so all of my numbers print on one line? On where do I want to get rid of the new line? Yeah, I want to get rid of the new line on 23. Because this is going to print a new line after every single number. More likely, I want to print a space after each number. Yeah. So you can see here that 3 is skipped every single time. So if we want to skip a specific condition of the for loop, but we still want to go throughout a range, the continue statement's really good for that.
Break at 3 will just
Yep, so if I change this to say break, then it will unconditionally exit when so here's what's going to happen. That's a good question. So it's never going to print past 3. So when we use a break statement, it's only going to break out of the loop that we're currently inside of. So when we break when j equals 3, that just stops our inner loop, which prints our numbers. It's going to continue to loop. Our outer loop, which essentially prints our lines, is going to continue on. But our inner loop, which prints our columns, our numbers, is going to just stop at 3. So yeah, if you put 3, or if you put break there, it's going to break out of the inner loop, but not break out of the outer loop, causing this result. So that's break statements. Mod really quick. Remember that we can do, here I'll just get rid of everything. We can say, essentially the only thing I would ever want you to use mod for is checking if it's odd or even. That's pretty much the only thing I want you to do. So we can test if a is divisible by 2 by saying a mod 2 equals 0. That means take a divided by 2 and then get the remainder. So essentially think of the modulus operator, the percent sign, as a remainder operation. So we're doing the division and we're getting the remainder. So then the statements that would be executed if a is divisible by 2 would go inside this code block right here. So just want to talk about the ceil and floor functions really quick again, because I think they're pretty important. Remember that in order to use the math functions, you would go include math.h, and then you would, let's just declare a couple variables. Let's say float a equals 10, float b, float b equals 3, and then let's say int res, and let's take res equals a divided by b, and let's printf res. So remember what that's going to do is take 10 divided by 3, which amounts to about 3 1/3. But when we store it in an integer, we're going to drop the remainder. So let's say we wanted to not drop the remainder, but round it according to the mathematical rules for rounding. We could also declare a third variable called float temp. And instead of storing it immediately into an integer, we could say temp instead. And then when we want to store it in res, we could say res equals round temp. And that will, if it's 0.5 or greater, it will round it up, and if it's less than 0.5, it will round it down. So remember that when we're using our math function, we need to say lm when we are using our compiler, and we need to say fn.c and a.out. So in this case, it's still going to round down to 3, but let's say I change this to 11. I think that might work. So with 11, our remainder is going to be, let's actually print out what our number is so we can see what's going on here. So we can see our remainder is greater than 0.5, so let's round it up to 4. So just use those functions if you want to, or just use the round function if you want it automatically rounded. If you want it to always round down, you can use floor to round it down. That will unconditionally round it down to 3. and then ceil to unconditionally round it down, or round it up, I should say, to the next whole number. So it's also, we don't have to store the result in an integer. We could say this is a float instead. Say float res. If we want to round our floating point numbers, we can totally do that. Not float. And it will look like that. So we can either store it directly into a integer, which will just convert it from a float to an integer, or we can store it directly into a floating point number. So that's math functions. The last thing I want to talk about today is random numbers. So in order to use random numbers, we need to say include standard lib.h, and then include math.h, or not math, but time.h. So remember that when we use random numbers to start out with, we need to say srand and then time 0 to get random numbers based on the current time. And then in order to actually get random numbers, we need to say rand. We need to call the rand function, and then mod let's say 20. And this will get us numbers between 0 and 19. So if we wanted between 0 and 20, we would need to do 21 instead. If we wanted numbers between 1 and 20, what we'd want to do is we want to say 20 plus 1. That will give us between 1 and 20 numbers, because rand mod 20 will result in 0 through 19 possible values, or the possible values for that expression will be 0 through 19, and then adding 1 to 0, any number between 0 and 19 will be 1 through 20 instead of 0 through 19. So that's the essentially really basics of random numbers. So again, this will result in 1 through 20. And then if I was to say, let's say I wanted to get 50 through 100, I would say rand mod 50 plus 50. It's because, so rand mod 50 would just give us 0 through 49. But rand mod 50 plus 50 will give us 50 through 100. Yep, so that's random numbers. That's, I think, all I have for you today. So I just wanted to review a couple concepts there. Any questions about any of the things I talked about today? So that's essentially a review of all the things we've covered recently. So you should be, aside from the random numbers, you should be aware of all the previous contents for quiz 3. Yep.
What was the rand time?
The srand time. So when I say so remember one of the things I talked about on Monday is that in order to use a pseudo-random number generator, we need to give it a seed value, a value that it's going to start out calculating the numbers at. So when I say time 0, what that's going to do is give me an integer describing the current time. You can, one of the things that computers do is they describe time in a lot of different ways. So so it will give me this number, which describes the current time. And you can see that number continuously increases as time progresses. Do you see that number? I'll put a new line. So when we say srand, so I'll run it again, run it again, run it again, run it again, run it again. So essentially what's happening there is 1 being added to that number every second that goes by. So by seeding our random number generator with the time, we're always going to ensure that we start out with a different value to get, again, pseudo-random numbers that appear random. So that kind of makes sense. Okay, so that's it for review then. So the one new thing I want to talk about today is the double type. So the double type is double the precision of a floating point number. So one of the things I talked about actually a long time ago is when you're using a floating point number, you might notice that some of the trailing digits do actually change depending on what you're trying to represent. So we can represent bigger numbers more accurately with more precision. That means that we can go more points to the right of the decimal, and they'll be more accurate than they will be for a floating point number. So not too big of a, not terribly significant for this class, but I want you to keep in mind that if you're using a float and you need more decimal precision, you need more decimals that are correct, then you should try and use a double type instead. So the example I have for that is this double type. So one of the actual there's something in C called a constant. A constant is essentially we could consider it a variable that has a specific value. So one of the things we can do when we include our math.h is we can get the exact value of pi to a good number of decimals for calculations. So we can assign something m pi, and it will be assigned the value of pi, and we can do that here too. So the only difference is, so this is what is actually going to be assigned. So this is a good approximation of pi per Google or whatever. But this is what, based on the type of the variable, the decimal isn't going to be approximated always correctly. So we're going to look at that really quickly. I'll try and explain a little bit more. Okay, so we can see here, so this is what pi actually is out to 11 decimals, and this is what the double type represents it as. So the double type represents it correctly all the way out to 11 decimals. But by using the float type, we only represent it correctly out to 6 decimals. And then after 6 decimals, we start to get results that don't match the rest of what pi actually is. And that's because depending on the number, float can only represent, I'd say, about 4 decimals accurately under all circumstances. If you want to try and represent more decimals than that, then you're going to get garbage numbers at some point. So just keep that in mind. If we want to represent big decimals, we want to use the double type instead. So that's that. Any questions about the double type? Remember that when we're using types, we would say, so that's just a new type we can use. So instead of saying float, we would use double. Yep.
Is there an advantage between using float and double? Like, let's say you only want to display 2 places after the decimal, and you use a double. Would there be an advantage for that rather than using float?
They're essentially the same. If you want to use double everywhere, you're not going to see a performance decrease. So think of double is just a better float. So that's all of the content I had for you today. So what I want you to do in class today is we're going to roll some dice. So what I want you to do is prompt the user for a number of sides on a die, and then prompt the user for the number of rolls. Each roll should be between 1 and S. Remember, S is the sides in the die, and then print n number of rolls. So if I would ask the user, enter the number of sides, they would enter 6, and then I would enter for the number of rolls, let's say 3, then I should expect your program to output between 1 and 6, so a 6-sided dice, 3 times. So a valid output would be 3, 2, 3, or something like that, or any number of random numbers. So create random numbers like we talked about in class. So in order to do between 1 and 6, what you want to do is rand mod 6 plus 1. Because if you just did rand mod 6, you get 0 through 0 through 5. But if you add 1 to 0 through 5, you'll get 1 through 6. So yeah, just start working on that, I guess. Any questions?
Now, what do you use Studio Live